So in this video, we are going to solve Zn equals to Z0 for any complex number Z0. So for example 5, we are asked to find Z such that Z power 3 equals to 2 plus 2i. We need to first find out what is the modulus for 2 plus 2i and the argument for 2 plus 2i. So this will equal to 2 square plus 2 square, and this equals to 2 square 2 and equals to 2 3 over 2. For argument for this, it is equal to pi over 4. So we know that this equals to 2 3 over 2 and cosine pi over 4 plus I sine pi over 4. Okay, we can rewrite cosine pi over 4 as pi over 4 plus 2k pi, 8k plus 1 pi over 4. And therefore this will be 2 3 over 2 cosine 8k plus 1 pi over 4 plus I sine 8k plus 1 pi over 4. And therefore we know that zk will equal to, after we take a cube root, this is 2 half, and this will equal to cosine 8k plus 1 pi over 12 plus I sine 8k plus 1 pi over 12, where k equals to 0, 1 or 2. 80 will equal to, this is actually equals to square root of 2 and cosine pi over 12 plus I sine pi over 12. Z1 will equal to square root of 2 cosine 9 pi over 12 plus I sine 9 pi over 12. And note that for this, it is actually equals to negative 1 over root 2 plus I 1 over root 2. And Z2, after we sub in k equals to 2, and this will be square root 2 cosine 17 pi over 12 plus I sine 17 pi over 12. Okay, we have a byproduct here that because the sum of the root is equal to 0, then the sum of this is actually equal to square root of 2. For the real part, you have cosine pi over 12 minus square root of 2. This is minus 1 over root 2 and plus cosine 17 pi over 12. That is for the real part. For the imaginary part, sine pi over 12 plus 1 over root 2 and plus sine 17 pi over 12 equals to 0. And this will give me this equals to 0, the real part equals to 0, and the imaginary part equals to 0. And therefore, cosine pi over 12 plus cosine 17 pi over 12 equals to 1 over root 2, and sine pi over 12 plus sine 17 pi over 12 equals to negative 1 over root 2. If we are going to draw all these on an Argand diagram, you will note that the model of z is equal to square root of 2. It means that it will be lying on, the point will lie on the circle where this is square root 2. However, it is not start from square root 2, but the first one is when this is pi over 12. So this is Z0. This will be somewhere here. This is Z1. And the last one, it will be here. So each of the angle here will be 2 pi over 3 again. When you join these Z0, Z1 and Z2, then you will see that it is still an equilateral triangle. I'm going to solve Z7 plus 1 equals to 0. So Z7 will equal to negative 1. We need to find out what is modulus, what is argument of negative 1. And we know that that is pi. So we can write as cosine pi plus I sine pi. And we can improve a little bit and say that this is cosine 2k plus 1 pi plus I sine 2k plus 1 pi. for any integer k. Zk will equals to cosine 2k plus 1 pi over 7 plus I sine 2k plus 1 pi over 7. And in this case, k is 0, 1, 2, 3, 4, 5, and 6. So we can list out Z0 equals to cosine
pi over 7 plus I sine pi over 7. Z1 will equals to cos 3 pi over 7 plus I sine 3 pi over 7. Z2 cosine 5 pi over 7 plus I sine 5 pi over 7. Z3 equals to cosine pi plus I sine pi. And Z4 equals to cosine 9 pi over 7 plus I sine 9 pi over 7. Z5 cosine 11 pi over 7 plus I sine 11 pi over 7. And finally, Z6 equals cosine 13 pi over 7 plus I sine 13 pi over 7.
So the sum of this is equals to 0. And we note that this is equals to a negative 1. Cosine of pi over 7 equals to cosine of 3 pi over 7. Cosine of 3 pi over 7 equals to cosine 11 pi over 7. And cosine 5 pi over 7 equals to cosine 5 pi over 7. So when you add up these and it's equals to 0, it means that the real part will be equals to 0. And the real part will be equals to cosine pi over 7 plus cosine 3 pi over 7 plus cosine 5 pi over 7. And with all this thing, which is the same, and it will be double of it, plus cosine pi, which is negative 1, is equals to 0. And therefore, we have cosine pi over 7 plus cosine 3 pi over 7 plus cosine 5 pi over 7. It is equals to a half. And we recall that cosine 2 theta equals to 1 minus 2 sine square theta. It means that sine square theta will equals to half of 1 minus cosine 2 theta. And therefore, it means that sine square pi over 14 will equals to half 1 minus cosine pi over 7. Sine square 3 pi over 14 will equals to half 1 minus cosine 3 pi over 7. And sine square 5 pi over 14 will equals to half 1 minus cosine 5 pi over 7. If we sum up all these, it will equals to half. You will have 3 over 2 minus 1 over 2 of the sum here, which is equal to 1 over 2 there. And this will give me 5 over 4. W is a complex number where W not equals to 1. W is a root of Z power 3 equals to 1. Show that 1 plus W squared equals to 0. This is simple because if W is a root of Z3 equals to 1, it means that W3 will equals to 1. And we have W3 minus 1 equals to 0. Factorize it, and since it's given that W is not equals to 1, and therefore this is equals to 0, and we are done. Show that 1 plus Wk plus W2k, this value equals to 3 if k is a multiple of 3, and 0 if k is not a multiple of 3. So this is also not difficult if k equals to multiple of 3. 1 plus Wk plus W2k will equals to 1 plus 3n and W6n. And W3 is equals to 1. It means that this will be 1 plus 1 plus 1, and that is equals to 3. If k is not 3n, then k must be equals to 3n plus 1 or 3n minus 1. So if k equals to 3n plus 1, 1 plus Wk plus W2k will equals to 1 plus W3k plus 1 plus W6k plus 2. And in this case, this will equals to W3n, and this is W1. This is W6n, this is W2. And since this is equals to 1, and I will have this is 1 plus W squared, and I already know that this is equals to 0. We are done. If k equals to 3n plus 2, then 1 plus Wk plus W2k will equals to 1 plus W3n plus 2 plus W6n 6n plus 4. So this will equal to 1 plus w3n w squared plus w6n w3 and w. This is 1 plus w squared plus w. And again, this is equal to 0.